Hello students, are you preparing for NEET, JEE or Karnataka CET? Looking for the right guidance to achieve your dream rank? Welcome to the Global Academy, the live coaching classes for the NEET, JEE and Karnataka CET. A single point and a complete solution for a competitive exam preparations, specially designed for the 11th and 12th or PUC first and the second year students, combining both syllabus as well as the entrance exam coaching. Our new batches starting from the 25th March 2026 for the academic year 2026-27. The course fees is 9,999. Now, with a 50% discount, you can enroll for just rupees 4,999 for the entire course. Limited seats are available, so enroll today. Call these numbers for enquiry, and you can also scan QR code for easy payment. Hi students, welcome to Global Academy. My name is Mushtaq Shaikh, generally called the Shaikh sir. I have a 37 years of teaching experience, and I'm your chemistry educator. Now let's start the first topic, the Unit 1 solution for class 12 or the PUC 2 students as per the NCRT. So these are the subtopics of the solution, the types of solutions, expressing the concentration of solutions, solubility, vapor pressure of the liquid, the ideal and non-ideal solutions, the colligative properties and determination of molar mass, and the last one, the abnormal molar mass. These are the subtopics of Unit 1 called the solution. Definition: solution is a homogeneous mixture of two or more components where its composition and the properties are uniform throughout the mixture is called a solution. However, or generally, the component which is present in a large quantity is called the solvent. Solvent determines the physical state in which the solution exists. This is a very important sentence because the solution which exists is depend on the solvent. If the solvent is gas, then the solution is gas. If the solvent is liquid, the solution is liquid. And if the solvent is solid, then the solution is solid. And that is because this sentence have a very important meaning, that solvent determines the physical state in which the solution exists. So this is the important sentence in this particular one. One or more component which is present in the solution other than the solvent is called the solute. Now, for example, we can take water plus salt. Salt completely soluble in water and hence it is a homogeneous. Therefore, this mixture is a solution. Here in this mixture, water generally present in a large quantity and therefore this is called as a solvent, and solute, the salt which is generally present in a smaller quantity. So the salt is called as solute. The next is the types of solutions. There are different types of solutions are there. the gaseous solution, liquid solution, solid solutions. Solute and solvent, and the common examples of these: in the gaseous solution, gas plus gas, it is a mixture of oxygen, nitrogen. For example, it is the air. Liquid gas, chloroform mixed with the nitrogen gas. The solid in gas, camphor, which is present in nitrogen gas. The next is the liquid solutions. Gas in liquid, oxygen dissolved in water. The liquid in liquid, ethanol dissolved in water. Solid liquid, where glucose dissolved in water or the salt dissolved in water, is also an example for the solid liquid solutions. The third one is solid solutions. Gas in a solid, the solution of hydrogen in palladium. The liquid solid, amalgam of mercury with sodium. Solid in solid, the copper dissolved in the gold. In this way, there are totally 9 types of solutions are present. 3 of gases, 3 of the liquid, and 3 of the solid. Totally, the 9 type of solutions are present. Now, generally the solutions are expressed in terms of concentration. So there are different units are there to express the concentration. Concentration is nothing but the amount of the substance present in the unit volume of the solvent is called as the concentration, or the composition of the solution is described by expressing its concentration. The first one is mass percentage. The mass percentage is defined as mass of the component in the solution divided by the total mass of the solution into 100. Now, for example, if a solution is described by 10% of glucose, then what is the meaning of that? What does it mean? 10% of glucose. It means that the 10 grams of the glucose is dissolved in the 90 grams of water, give 100 grams of solution. Similarly, the second one is the volume percentage. Similar type here, defined as the volume of the component divided by the total volume of the solution into 100. Now, for example, 10% of ethanol solution. Now, the ethanol is a liquid and water is also a liquid. Ethanol present in a water. It means that 10 ml of the ethanol is dissolved in the required amount of water. Total will become 100 ml. Means the 90 ml of water, so that it become 100 ml. The third one is mass by volume percentage. So another unit which is commonly used for a medicine or pharmacy is mass by volume percentage. Generally, in terms in the medicine, quantity will be in the mg, milligrams, small quantity, then it is determined in terms of volume percentage. So this is a mass of the solute dissolved in 100 ml of solution, which we called as mass by the volume percentage. The next, the unit is called as part per million. Now, this is also one more important unit, which is generally used to determine the trace component present either in the air or in the liquid. Very small percentage of the component which is dissolved or present. This is determined in terms of parts per million. When the solute is present in the trace, so very small quantity, it is convenient to express the concentration in parts per million and is defined as parts per million is nothing but number of parts of the component divided by the total number of parts of the component in the solution into 10 raised to 6. So this is a 10 raised to 6. So that is the definition of what is called as the parts per million. That is the fourth one. The fifth one is mole fraction. Now this is defined as the ratio of number of moles of the solute divided by the total number of moles of the solute and the solvent present in the solution is called as the mole fraction. The mole fraction of the component, nothing but the number of moles of the component divided by the total number of moles of all the component. Now, for example, in a binary mixture, binary means 2. Bi means 2, binary means 2 component. There is one is A, another is B. There are 2 components are there, and hence Na is the number of A as well as Nb is the number of the B, and hence the mole fraction is equal to Na divided by Na plus Nb. Similarly, we can also write for B. So Xb, which is equal to Nb divided by Na plus Nb. So this is what is called as the mole fraction. The mole fraction of any substance that is called as, that is Xa plus Xb, is always equal to unity, is equal to 1, because just put these values here and you will get 1. Hence the mole fraction of the solute and the solvent in the solution is always unity. That is, you have to remember. Next is the molarity. There are 2 are there. One is the molarity. You can see one more is molality. It is a molarity. Molarity is generally represented by letter M, capital M, and is defined as the number of moles of the solute present or dissolved in 1 liter of the solution, called as the molarity. Defined as the number of moles dissolved in 1 liter of the solution. That is what is called as the molarity. So molarity is the moles of solute divided by volume of the solution in liter. So this is a one equation. We will see the other equations for molarity in solving the problem. When we solve the problem, we will come to know there are different ways where we can express the molarity. So next one is the molality. Molality is represented by the small m. Now, as you know that molarity is represented by capital, and this is represented by the small m. It is also defined as the number of moles of the solute dissolved in 1 kilogram of the solvent. This is an important difference between the molarity and the molality. Molarity 1 liter, whereas molality it is kilogram, dissolved in kilogram of solvent, and this is a solution. Here you can see it is a solution and this is a solvent. That is the main difference between the molarity and molality. Molality, once again, the moles of the solute divided by the mass of the solvent in kilograms. That is what is called as the molality. So these are the different units in which the solutions are expressed. Importance are 3: mole fraction, molarity, and molality. These are the very important expressions where you have to concentrate. Next is the solubility. What is the solubility? The maximum amount of the substance that you can dissolve in a specified amount of the solvent at a specified temperature is called the solubility. The maximum amount of the substance you are dissolving in 100 ml of solvent at a specified temperature, at a room temperature, called the 25 degrees centigrade, that is the solubility of that particular substance. The solubility of the solid in liquid depends upon different states. The first one is the nature of the solute and the solvent. The nature of the solute as well as the solvent. Okay. Now, what is the meaning here? Just see that polar solvent dissolves in polar solute dissolves in polar solvent. Polar solute dissolves in polar solvent. For example, the sugar or salt, it dissolves in water. It dissolves in water. On the other hand, the non-polar solute dissolves in non-polar solvents. What are the non-polar solutes? Like anthracene, or you can take the benzene, etc. They dissolve in non-polar solvents like benzene, toluene, carbon tetrachloride, so on. Now the question arises, if you take water and if you add a non-polar solvent, is it dissolves? No. For example, if you take the anthracene and if you want to dissolve in water, the anthracene will not soluble in water. Or you can take the naphthalene, that will not soluble in water because it is a non-polar solute and the solvent is a polar solvent. Similarly, if you take the sugar and try to dissolve in benzene, the sugar will not soluble in the benzene because sugar or salt, they are the polar solute, whereas the benzene is a non-polar solvent which is not soluble in each other. So here, like dissolves like. That is the tagline which is we can use or we can write. Like dissolves like means polar dissolves in polar, non-polar dissolves in non-polar solvents. The next one is the effect of temperature. This is important because the MCQs will ask on this particular part. Okay, if the dissolution process is endothermic, if the dissolution process is endothermic, what does it mean? There are two types, you know that. One is endothermic, another is the exothermic. Endothermic, where the heat is absorbed. For example, if we take the water in a test tube and you add a salt, any salt. For example, if you take the sodium chloride or you take the ammonium chloride, you dissolve. Okay, and you can feel that the temperature of the water decreases, and hence the dissolution is endothermic. It takes the heat of the solution, means solvent, and it dissolves. In such cases, when delta H of the solution is greater than 0, delta H of the solution is greater than 0, the solubility increases with the rise in temperature. Clear? So this is important one. Similarly, if dissolution process is the exothermic, that is delta H of solution is less than 0, then the solubility decreases with rise in temperature. I think you might have feel that if you take the test tube and you take water and add concentrated acid, either it is sulfuric acid or nitric acid, you can feel that the test tube become very hot. Why? Because here, when you add the water and the concentrated acid, there is a lot of heat is liberating, and the reaction, the solubility of the reaction is exothermic, and because of that reason, lot of heat is generated here, and hence the in these cases, when the temperature is increased, the solubility decreases. So in case of endothermic, As the temperature increases, solubility increases. As the process is exothermic, as the temperature increases, the solubility decreases. So this is the important the point of the solubility. Now let's see the solubility of gases in a liquid. As you know that there are many gases soluble in liquids, okay, many gases, particularly in water. In water, there's a large number of gases are soluble like oxygen, nitrogen, hydrogen, carbon dioxide, monoxide, and so on. The solubility is of the gases in liquid is expressed by the term called absorption coefficient. Is a absorption coefficient. The solubility of the gases in liquid is expressed a term called absorption coefficient. The absorption coefficient of is the volume of the gas in liters, okay, that can be dissolved in 1 ml of liquid at STP. What is the STP? STP is standard temperature and the pressure. Now that is about the solubility of gases in liquid. Now the solubility is depend on one or two factors. The one factor is the nature of the gas. The second factor is the nature of the liquid called as the solvent. Now first see the nature of the gas. The gas which can be easily liquefied are more soluble in water. The gases are of two different types. One we called as the temporary gases, the another we called as the permanent gases. What are the temporary gases and what does it mean? For example, if you take carbon dioxide or you take ammonia gas, these gases can be liquefied at room temperature. Such gases we called as the temporary gases. On the other hand, the gases like the nitrogen, hydrogen, the helium, and so on, they cannot be liquefied at room temperature. Hence, these gases are called the permanent gases. So, the temporary gases soluble very easily in liquid, whereas the permanent gases are not soluble. Nature of the liquid, the gas which are capable of forming the ions in the aqueous solution are much more soluble in water than any other solvent. Now, some gases, for example, if you take hydrogen chloride, HCl generally we say hydrogen chloride. Hydrogen chloride easily soluble in water because it forms ions. It forms ions when it is dissolved in water. H plus ion and Cl minus ion. So such gases which forms ions, they easily soluble in solvents like water other than the other solvent. Now here we'll stop and we'll continue in the next class and we'll solve some problems, particularly we can see in the NEET as well as the KCET or Karnataka CET in the next video. Thank you.